How's everybody doing? So we got a small audience here, so we're going to tailor this session to make sure that all of you get what you want out of this session. I'll keep plenty of time for Q&A because I know this is an interesting topic for several people, so there might be a lot of questions, curiosities. Just so that I know my audience, how many people familiar with SQL Server, the box product on-prem? You guys have used it, historically been familiar with it. Excellent. So what I'm going to do today is I'm going to spend some time, just talking about the next version of SQL Server and how it's going to fundamentally change the way you've previously thought about SQL Server with a focus on Apache Spark. So we're bringing Apache Spark to SQL Server. I think if you're familiar with SQL Server, right there brings up a lot of questions on what does that even mean, how does that work, how a customer is going to use it. So we're going to spend the next half an hour or maybe 20 minutes talking about it. We'll do some Q&A after that. I'm going to hang around after the session if anybody has questions. Landscape of data. I think you see these statistics in more sessions than one. But these are really important statistics, right? These play a very dominant role on how we think about our business and where we seek enterprise customers and even small customers, SMC customers investing. Like in 2016, 16.1 zettabytes of data was generated. In 2025, that's going to be 163 zettabytes. Somebody is going to need to process this data, right? This data is not being generated to get wasted. People are working hard on driving more and more intelligence out of this data. We've seen this historically. SQL Server has been a product that's been used to analyze data for the last 25 years. So as we see this growth of data, we're constantly thinking, how do we fundamentally change the product to make sure that all of our customers across the world can take advantage and drive insights of this very large set of data. When we talk to all of the CIOs, and here I'm talking about the customers who have traditionally been SQL, it's very clear and it's very evident that all of them are investing in a renewed data strategy, right? People who have been traditional SQL shops, they've been using the RDBMS. They've mostly used it to store transactional data. Historically, they are the people who've been working with data in very large companies. As more and more data gets generated, they are looking at how to change and adapt to that world. When we talk to these CIOs, we clearly see that some things have changed in the last 25 years. Models are much more dynamic. We're looking at all of these customers. There's a big data side of the house, and we work with a lot of those customers. But in the traditional SQL side of the house, when we query those customers, almost all of them are looking at investing in some sort of big data, whether that's on-prem or in the cloud or a combination. When we ask about ML, predictive analytics or other kinds of ML, we see that about 74% of these leaders of companies would like to use some sort of ML. So with SQL Server 2019, which is a product that's available in public preview today, we're fundamentally trying to change the game, and we're going to focus on three big themes for this product, right? We're going to focus on integrating all of your data. SQL Server, if you've traditionally thought about it, you get a SQL Server box and you put data in the SQL Server, and then you run queries on that SQL Server, right? Whether that's transactional data or other kinds of data, you're running queries within the data that's in the SQL Server. We're going to change this, and I'll talk a little bit about it, on how SQL Server can now access all kinds of data, not just the data that's in SQL Server. We're going to talk a little bit about how you can manage all of this data, right? So once you can access all of this data, once you're generating so much data, how are you going to manage all of this data? And how you can analyze and build intelligent apps on all of this data. How many people have deployed a SQL Server? Everybody familiar with SQL Server has traditionally, scaled vertically? Does that concept make sense? So for the big data folks in the room, Spark, one of its big value props is it scales horizontally. It's super powerful, right? Like you can add more machines, and you can grow your Spark workload. SQL Server has been an engine that has historically scaled up. which means if you wanted a bigger box, if you wanted more, store more data, analyze more data, you'd go and buy a bigger box. With SQL Server 2019, we're going to show how we're changing some of that. So sort of looking at integrating the data. So think about a company, large enterprise. These are companies that are not starting from the ground up, right? They're not saying that we built a company today and we're going to start gathering data today. These are companies that have had data in multiple different databases for years and years, and they would like to harness the power of this data. One of the things that we are building in SQL Server 2019, and a little bit of this was available in previous versions, is the ability to go to SQL Server, to use the T-SQL syntax and be able to query data from wherever the data exists in your enterprise. That data could exist in SAP HANA, that data could be in Excel files, that data could be in cloud NoSQL databases such as MongoDB or Cosmos DB. That data could be in competitive relational databases, such as Teradata, or even other instances of SQL Server that's running on your enterprise. Or, and this logo is probably going to change here in a little bit, but the data could be in a data lake that you've invested in on-prem using Cloudera or Hortonworks. We're bringing technology so that you can query all of this data from SQL Server using SQL syntax without having to move the data. Internally, we call this data virtualization. So the idea here is you can go to a SQL Server front end with SQL Server 2019. You can define tables that actually map to data on all of these different sources, and you can run queries on that data without ever having to move the data. This is going to position SQL Server to be the single one-stop shop where you can not only do traditional SQL queries, but query data from anywhere that exists in your enterprise. And then, so why do we do this, right? Like, what's the end game here, and why do we think that this is powerful? This is powerful because when we look at the SQL Server business, when we look at our customers and what they do, right, there's the power of the engine that they utilize. But they have built a lot of line of business apps. So if you look within your enterprise, you're going to find in different departments a lot of line of business apps that are built on SQL. And these apps would traditionally query SQL, which means they would use data in SQL. With this power, those same applications can now query data that's anywhere. So your line of business applications don't need to change a whole lot, and you get to harness the power of all the other data that you have within your enterprise, without having to move the data. One of the things that we have also added is, so now you're going to start to query this data, right? You're going to query data from Oracle. You're going to query data from, Cosmos DB. When you're querying from so many different places, you're going to get bottlenecked on that one SQL instance, which is how it's traditionally worked, right? There is one single SQL Server master instance that's running, maybe with a couple of replicas. We're also adding the ability to, build compute pools. These are basically pools of SQL servers that run, and I'll talk about how deployment works, but these are pools of SQL Server that run as part of SQL Server 2019, where they can do the queries on all of these external databases and then aggregate those queries, giving you a good scale-out performance architecture. So, if you think about some of the scenarios that are interesting here, imagine if you're you're a bank, right? And traditionally, a bank, when they were looking at customers, they were looking at customers where they lived, how long they have been a customer, what's their average balance, things like that, things that were traditionally stored in SQL. In the modern day, they want to do much more. They want to have all of that data, but they also want to, do analytics on how the users are using the online product. They want to get other data about the user, which might not necessarily be stored in SQL. That might be stored in a NoSQL database, such as Cosmos DB, or it might be stored in a data lake that's powered by Cloudera or Hortonworks. You can now, with this, use SQL to query all of that data across all of these diverse products and get a unified view of that customer. And you can do this at scale. You can do this in a very performant manner with the scale-out architecture that we're building. So we talk about first part, which is getting like the ability to read data from all of the different places. How do we manage data? Like, what are we building in SQL Server? So this was reading from external sources. One of the biggest things that we're doing is we're adding Apache Spark to SQL Server. Not Apache Spark working with SQL Server, but when you get SQL Server 2019 moving forward, you're going to have Apache Spark built into that. What does that mean? Like, what does that look like? The new version of SQL Server, and we'll have a much more deeper architecture on the next slide, is deployed on Kubernetes. And in Kubernetes, we're going to have what's called a storage pool, where you're going to have these pods that are running Apache Spark, HDFS, and SQL Server on the same nodes. And you can scale out those nodes to the extent that you want. So you get SQL Server 2019. You can ingest all of your big data in HDFS in SQL Server 2019. You can run ML. You can do a bunch of analytics in Apache Spark within that product. And we'll show you some of the tools that we have for that. Once you're done with your analytics, you generate a high-value table. That table seamlessly can be accessed from SQL Server. No transition, no connectors, nothing more needed. So it's offering you a one-stop shop to not just do big data analytics, but do big data analytics and SQL in the exact same place. So we'll bring up our eye chart a little bit, and we'll build upon this. Again, if you're familiar with SQL Server, you see this SQL master instance. Let me try to use my fancy. This is what SQL Server has traditionally been, right? It's been one machine with maybe a couple of replicas that runs SQL. And like I mentioned earlier, you want a bigger instance, you buy a bigger machine. With 2019, we're deploying this. This is one part of SQL Server 2019. It's being deployed in a Kubernetes container where you're going to have this concept of a storage pool, which is essentially a bunch of Kubernetes pods that are running Spark, SQL Server, and HDFS on the exact same node. And what this is going to allow you to do is it's going to allow you to bring your big data to SQL Server, use Spark to query it. Once you're done with that, once you've gotten the data set, then use SQL to further query that data, all in the same product. We're also going to have the ability to scale out compute pools. So again, once you start querying this data, if you want to scale out how the compute in SQL works, you can add as many nodes as you'd like. This is what I spoke about earlier. You can have compute pools, scale out compute pools to speak to external data. You can also scale out storage independently of compute by having data pools, which allow you to increase your storage for SQL. So I'm going to take a pause here because I've been to Spark Summit a couple of times. I talk a lot about Spark. This is a very different topic. So any questions? Good.
The container, is that 3 individual containers in a pod, or is it just one container with all 3 components in?
Sorry, where are you talking about the containers?
Kubernetes pod and storage pool. You've got SQL Server, Spark, HDFS, data node.
Yeah.
Are those individual containers, so we have 3 containers in the pod, or is it one
So
container
I will have
in
to
the pod?
check on that. I believe it's 3 containers, but I'll have to check on that.
Okay.
The idea of putting it in the same pod is the fact that Spark, of course, this is like an on-prem deployment of Spark over here. So you're using Spark with HDFS, but the SQL engine is running there so that the SQL engine can directly read from that HDFS in a scale-out performant manner. Any other questions? Go ahead.
What's the relationship to this and Azure SQL DB going forward? Are they going to be completely
Excellent
separate?
question. I was hoping somebody would ask that question. So, the term SQL is used a lot. In fact, there are probably like 4 other sessions on SQL going on. And the question is, what's the difference between this and Azure SQL DB? So at Microsoft, we have a couple of different SQL products. SQL's been our bread and butter of our data business for a really long time. There is SQL Server, which is what I'm talking about. This is the traditionally on-prem product, which is now running in Kubernetes, which means while it's an on-prem product, you could deploy it in a Kubernetes service in the cloud. Azure SQL DB is the PaaS version of SQL that's running in the cloud. We have a couple of other versions depending upon customer needs. We have a managed IaaS version as well called Azure SQL MI that runs in the cloud as well. But what I'm talking about is the on-prem version, the traditional SQL Server version. That's where we are starting out this idea with. And depending upon the feedback and how things go, will shape the roadmap for our other products. Go ahead. And I was hoping that's one of the questions that somebody would not ask me. The question is around licensing models, and this is probably not the right forum for me to talk about how the licensing model works. But I'll be happy to take that question right after the session and talk about how you can get more information. But
and second question, so it's about SQL Server 2019.
Could you speak into the mic?
Yeah, sorry. And what about the version on SQL Azure? Will we have also that kind of features?
So that was actually the same question that Chris from M&J asked. But right now we're bringing it to the SQL Server on-prem product. And again, these lines start to get blurry because the on-prem product can also run in the cloud as IaaS. You're talking about the PaaS product, and depending upon what the customer uptake is, the feedback that we get, we're going to shape the roadmap for those products.
Yeah, and as well as for the Polybase features, as today it's not available in the SQL Azure.
Yeah.
Do you know is
so the Polybase features the ability to query external databases. I can connect you to the right team for Azure SQL DB. You can talk about that a little bit more. So. The vision here again is you're getting all of this data. You can use this single product to do big data analytics. You can do this single product to query external data sources, because one of the things that we don't want you to do, or we know it's going to be hard, is if we tell you, hey, we have this new product, hey, we're Microsoft, we have this new product, all of the data in your enterprise, bring it here, and then awesome things will happen. We've built it in a manner that your data can stay where it is for now. You can bring in new data into this product that can be unstructured data or traditional SQL data, and you can query it from one single interface. Let's see. We're going to have, with this version of SQL Server, we're also announcing a number of new management tools. And if you enroll yourself in the preview and start playing with these tools, they're going to look very much like cloud-first tools. It's an on-prem product, but we're going to have monitoring. You have Spark. You'd like to know how your nodes are doing. Do you need to add more nodes? What's the performance looking like? We're going to have very rich dashboards for the entire slew of the operations that we perform, from Spark to traditional SQL to all of the other things. You want to see how your HDFS is performing? We're going to have a dashboard available for that. That's on the monitoring side. So taking a little bit of a deep dive into, so you get the product, how is all of this put together, right? Like this is what the Kubernetes container, the cluster looks like, right? You can see there is in the same cluster, so this is the SQL 2019 product. You can see there's a SQL instance running. You can see there's the storage pool running, which is actually running your HDFS and your Spark. You can see a number of other things that are running in there. So again, it's no longer limited to a single machine deployment. It's really a cluster form factor that SQL is being deployed in over here. We have a new product, and we just released this last week. So the name has changed. This one says Operations Studio, but it's called Azure Data Studio. So people familiar with SSMS, SQL Server Management Studio? Think of this as the new incarnation of that. You can not only write SQL queries in here, you can write Spark queries in here. So here what you're seeing in the screen is I have connected to a SQL instance. I'm creating an external table. You can see that I can run my Spark jobs right from within this instance in SQL Server. I don't have a screenshot of this, but you can have notebooks. The notebooks that we're familiar with these days, Jupyter-style notebooks. You can have Jupyter-style notebooks that not only do Spark, but they also do SQL. Think about that. Like you're getting this interface which has Spark and SQL all provided in the same operational tools. The idea here is that the same set of engineers could go and run Spark, create those tables, and then go run SQL. Well, SQL is already running in there. Use SQL to query the same tables. Not move data from one place to the other, not push something, not use two products separately, but do all of this in one single product. So, we show how you can submit a Spark job that populates a table. The table can be read from SQL over here. Again, I would encourage all of you guys to go try this out. I'll put a link at the end on where you can go and sign up for this. So we are in public preview today. You still have to sign up. And we're going to release this product next year. So it's going to be made available next year. There's a couple of other things. Analyzing the data. Sure, people here, come here, listen to a lot of talk about machine learning. We're also bringing machine learning into SQL. So the way we think about this, right? If you look at a traditional Spark pattern or a cloud-first pattern, you have data that's coming in from a bunch of places, right? And in a cloud pattern, you'd put this data into some sort of remote storage, and then put some sort of event mechanism to sort of read this data, maybe something like Kafka. We'll have, because we have Spark, you can use Spark streaming to analyze the data. You can run all of the Spark ML models. Just this is SQL Server. In SQL Server, you're running streamed data. You're running a real-time ML model on that data, and you can store that data. Not only that, we have ability for you to operationalize your machine learning models. So what you can do, and this is going to take a little bit of thinking through, but what you can do is you have all of this data. You go to Spark, you build a model. You can take that model and use it in SQL Server. So when you are querying in SQL Server, you have 6 columns. The 7th column could be an output of the machine learning model that was generated in Spark using all of the big data that you have. So pretty powerful stuff. Our idea is bringing all of these things together. As we look at our SQL on-prem customer base, we see that all of them have a need for big data. And what they're doing today is they're putting disparate products together and trying to make this happen. We think that there is a need for big data. We clearly see at Microsoft that Spark is emerging as a winner. So we want to take Apache Spark, we want to put it in SQL Server, and we want to offer you this product as a complete end-to-end data analytics product. So again, just recapping some of the things. It has data virtualization built in. So with using the same product, you can read data from anywhere, from any source that we support. Reading of that data can be scaled out very easily by increasing the number of SQL servers running in your compute pool. You get Spark built in. While you can read from external HDFS, you get HDFS and Spark that's built into SQL Server, running right side by side from SQL Server. Scalable, so you can scale that to your needs. You can grow that to wherever you want. And it's an AI platform. The fact that you can do ML, not only do ML in Spark and build the models, but also operationalize the models as a column in SQL, allows you to have predictive analytics and a bunch of other machine learning things. Like think about fraud detection when transactions are coming in, right? Your fraud detection algorithm, but your transactions from your customers come in through SQL. You can run inline the machine learning algorithm in SQL that you've built in Spark to be able to detect fraud and stop transactions and things like that. So that's our little preview around SQL Server 2019. There's a lot to digest over there, so we would encourage you to go and try out the product. You can sign up at that link. We'll make the slides available, but if people want that link, I'd encourage you to take a picture of that, because the slides might be a couple of days late. And I'll take any questions.
Suppose that the customer already have some Spark implementation or Databricks. Is that possible to use SQL to connect to HDFS, or we need to use these Kubernetes and deploy another instance of Spark?
The short answer is yes, you can connect. In fact, I'll give you a couple of different instances, right? So if the customer already has Spark, right, it is unlikely that he's going to want to connect from SQL to Spark. He's more likely to want to connect to the output that Spark has generated. So if it's an on-prem product, that if you're running Spark on-prem, you're likely running it with Cloudera or Hortonworks, and your output data set is stored in HDFS. We can connect to that from this SQL server. If you're running it in the cloud, we can connect to that HDFS or that blob storage or the other storages in the cloud from this SQL server, and go and read that data from that without actually moving all of the data. So that's possible. Of course, our hope is as you build your architectures, like that's a stepping stone, right? As you build your architectures, eventually you start putting the HDFS data in here as well, because now we offer Spark that's built in.
Hi. So what level does the virtualization work? So you say you can get the data from any of these places, but can you do like join table A in one data store to table B that's in another?
Yes, absolutely. And in fact, maybe I should have spoken about that a little bit more. The whole idea of having virtualization across these disparate sources is so that you can join data from table A, let's say in a different instance of SQL Server or Oracle Teradata, from a completely different source like Cosmos DB. You're absolutely able to do that, and the compute pools allow you to do that in a performant manner because they read the data and then they do the aggregations in SQL for you. Any other questions? All right. Thank you guys for your time. Thank you for listening to me.